Assalamu alaikum. We're going to discuss our next lecture, and that's about cylinder and quadratic surfaces. I'll give you the definition of a cylinder. We're having curve C, so we're having this curve C in a plane, and let L be a line. This line is not in the parallel plane. This was the XY plane, it's not in the parallel plane, it's parallel to Z axis. So then the set of all lines that are parallel to line L and intersect C is a cylinder. So we have here these lines, they are parallel to this line L, and we say these are the all lines, and these lines which you constitute, that's known as cylinder. Now if we, in the second example, this is the example I take here, x squared plus y squared equal to 4, xy plane, and this curve is our circle. So we have this circle, and then we are in xy plane, and then we are having the lines. So this is a base curve, this is known as base curve, and this line is known as directrix. It's also known as ruling. Both words are used in calculus books. Is ruling, or we say. And we are having here, this is our cylinder. We say the surface we are going to get here in this way, we call it a cylinder. Now you can see, if we move this line here, it's not an xy plane, and we take all the lines parallel to this one, then the cylinder is moving. The cylinder is moving. If we move our line L like this one, then the cylinder will move like this one. So we will get here the cylinder will be like this one. So this cylinder is moving with the directrix, the line, because these all lines to the cylinder, they are parallel to this line and they're intersecting the base curve. We have here, this is our base curve. They are intersecting, this is our base curve. This is our base curve. And here this is known as ruling. I will say this is our directrix. I take another example. I am having here in xy plane, this is my xy plane, I'm having here a parabola type picture here xy, and this is my base curve. Now if I take the 3 dimensions, this is my example 3, So if I take here z axis, and this is my y axis, and this is my x axis, this is my z axis, my origin. Now my base curve, if I take this base curve in my xy plane, so then I will going to get here the picture like this one. This is my base curve. So if I take this as line, as directrix, I take all the lines parallel to this line and intersecting the base curve, then I'm going to get here the picture like this one. This here line, this is intersect the base curve, and I am having here this type of curve, and here is this is intersecting the base curve. This is intersecting here the base curve. I take all the lines parallel to the line L. So this is my all lines, and here from the back side I have this line L, here this line. So in this way we are going to get here the geometrical figure. As this geometrical figure we say this is our cylinder. So again we are having here this as base curve, and this line is our ruling. We say this directrix. Now if you move this line, then this cylinder is moving. As we have this cylinder and cylinder is moving, similar to this one, this cylinder is also moving. In this example, we are having this line in yz plane. Its line is 2z plus y equal to 0. When y equal to 0, z is equal to 1. When z equal to 0, y equal to 2. This is a line. So this become our base curve in our xyz plane, and this is our directrix, our line. Now we take all the lines which is parallel to this one, and we can see here what's going to happen. When this line parallel to this one, this is a line parallel to this one, and I take the line parallel to the given line because they are intersecting the curve. So I take all the lines. So these are all lines which are intersecting the curve parallel to given line L, and this will be our cylinder. This is our cylinder. Very interesting idea that we are having here. The curve is actually like this one. If we take these notes, this page, it's like this one. It's hollow from inside. It's like this one. This is our base curve, and these are the line parallel to that axis. We all take all these lines, and we get here figure like this one. And this is our line, and this is a figure like this one in yz plane. So we call this one as a cylinder. So I can just make one more picture for your reference. This here, example 5, and I'm given here the curve, base curve given to me is z equal to 1 minus y square. This is yz plane, and this is my z-axis, and this is my y-axis. And if I draw my curve and y equal to 0, y equal to minus 1 and plus 1, z equal to 0. So this value of z is equal to 0. And when we're having y equal to 0, z equal to 1. So I'm having here this as my base curve. Now I show this base curve, and now I want to show it as a cylinder. So my axis is the x-axis. So it's my z-axis. This is my y-axis, and I take here x-axis. So the axis will not in y-z plane. So we can have here this is extend to this one, and I just draw my base curve. This is my base curve. This is my base curve. Now I take all the points, other lines which parallel to the line L. I take this as line L, and I take all the lines parallel to this one, this line parallel to this one, this line parallel to this one, and just make here the curve. And this line, I draw all the lines parallel to this one, and intersecting the line C, and this become for me a cylinder. So that's another definition. This is my cylinder, and here given is my line, the directrix ruling, and this is my base curve. So these are the definition here. This is a line in YZ plane, but it's a cylinder in XYZ plane. This is a parabola in YZ plane, and this is a cylinder in XYZ plane. This is a parabola in our XY plane, and then this one is a cylinder in XYZ plane. This was the ideas about the cylinder. We'll move to the quadratic surface.